Hey everyone, today we're going to do something really cool. We're going to take a simple piece of Java code, basically just a blueprint, and step by step we're going to turn it into a smart, self-sufficient object. Let's get into it.
So this is the big question for today, right? In programming, a lot of the time we start with these simple containers that just hold data. But the real magic, the real power, happens when we teach those containers how to act, how to basically think for themselves. So how do we breathe that life into our code?
Okay, so meet our subject for today, the box class. And right now, it's just a digital box. It knows exactly three things about itself. Its width, its height, and its depth. And that's it. It's just holding data. It can't do anything with that data. It's basically just sitting there waiting for instructions from the outside world. And that leads us to our first problem. If we want to, say, calculate the volume of our box, we have to do all the math outside of the box class itself, in our main program. We have to literally reach inside the box object, grab its dimensions, and multiply them together. It feels clunky, it's disconnected, and imagine if you had 100 boxes. You'd have to repeat that logic over and over again. So how do we fix this? Well, our first and probably most important upgrade is to give our box some actual behavior. And we do that by adding methods. This is the moment where our dumb box starts to get a little bit smarter. A method is really just a named block of code that belongs to a class. You can think of it like a verb, an action that the object can now perform. So instead of just having nouns like width and height, we can give it a verb like calculate volume. It's basically Java's way of giving an object its own little subroutine. And wow, this just shows you the difference perfectly. On the left, you've got that clumsy external calculation. But on the right, it's clean, it's intuitive, you can read exactly what it's doing. We're just telling our box object, myBox1, to run its volume method. We're asking the box to figure out its own volume. That's a huge step forward in just keeping our code organized.
But here's the little bit of magic happening behind the scenes. Inside that volume method, how does it know which width, height, and depth to use, especially if we have many boxes? Well, it knows because the method is always called on a specific object. When we say myBox1.volume, the method just implicitly understands, okay, I need to use myBox1's data. It's all about context.
All right, so our box can now announce its own volume, which is great. But we've already hit another snag. Right now, our method just prints the volume straight to the screen. And that's not always what we want, It's not very flexible. Yeah, this is the key question. What if you need that number to calculate something else, like shipping costs, or to figure out if the box will fit in a truck? Just printing the value is a total dead end. We need the method to give the value back to whatever part of the program asked for it. So the whole fix comes down to this one change. On the left, that void keyword basically means this method returns nothing. But on the right, we change void to double. That's a promise. The method is now promising to give back a number. And then we use that super important return keyword to actually send the calculated value back to the caller. Let's just walk through it real quick. Our main program calls the method goes off and does its calculation, then that return statement acts like a delivery service, sending the result back out. And finally, our main program can catch that delivered value in a variable. Now our box isn't just shouting its volume anymore, it's helpfully providing it as data we can actually use. Okay, our box is getting seriously useful. But take a look at how we're still setting it up. We're reaching in from the outside and setting each dimension one by one. There's a much smarter way to handle this. This just feels wrong, doesn't it? It's 3 separate lines of code just to define one box. It's so easy to make a mistake. Maybe you forget to set the depth or something. Good design says we really shouldn't be fiddling with an object's internal data directly like this anyway. So to fix this, we need to quickly get 2 words straight: parameter and argument. It's actually pretty simple. The parameter is the placeholder inside the method. Think of it like a parking spot waiting for a car. The argument is the actual value, the car, that you send to the method when you call it. And here is the result. It's so much better. We create a new method, let's call it setDim, that has parameters for width, height, and depth. So now, instead of 3 clunky lines, we have 1 clean, descriptive line of code to set up our box. It's safer, it's more readable, and it's way more efficient. We are so close to perfect. But think about it for a second. We're still doing 2 separate things. First, we create an empty box object. Then, in a second step, we call setDim to fill it up with data. Couldn't we just do it all at once?
This is the last piece of the puzzle. We create the box, then we initialize it. Yeah, it works, but it feels like an extra step we shouldn't have to take. What we really want is for a box to be born fully formed and ready to go from the very beginning.
And the answer is something called a constructor. A constructor is this special kind of method that runs automatically, just one time, at the exact moment an object is created. Its whole job is to handle that initial setup. You'll notice it always has the same name as the class, in this case box, and it has no return type at all, not even void.
And here it is, the ultimate transformation. On the left, our old two-step process, and on the right, the final, elegant, one-step solution. We are creating and initializing our box in a single, powerful, and easy-to-read line of code. Those arguments, 10, 20, 15, get passed directly to the constructor as the object is being born. So let's just recap our box's incredible journey. We started with a dumb box that was just a container for data. We made it self-aware by giving it a method. We made it helpful by letting that method return a value. Then we made it customizable with parameters, and finally we turned it into a self-building box with a constructor ready for action the moment it's created.
You see, this progression from a simple data structure to a smart, self-initializing object, that is the absolute heart of object-oriented programming. We've just given you the blueprint for creating powerful, reliable, and really elegant code. So the only question left is, what are you going to build with it?